Hello everyone, this is Mr. Rodriguez again. I wanted to clarify some notes. These were some notes that I had written up before, and I wanted to make them more available for you in the same format that I gave you the notes before, and also give them an ability for you guys to actually review the notes online via video as well as PowerPoint. So what I did was I took basically the same notes and hopefully I made it better and typed it up for you so that way you can have it for download. I believe this is the piece that's missing from latitude and longitude lines, so I just wanted to add this in. Now we're talking about here the Earth's reference system. Now for the Earth reference system, the Earth's reference system is actually broken up into a series of latitude and longitude lines. Okay, I wanted to show you this view of this file here. As we can see here, we can see that this is a picture of a globe, and it's basically like the Earth. And what we can do is we can actually take this object and take a look at the latitude and longitude lines. As we can see here, latitude and longitude lines become the reference system built to locate objects on the Earth's surface, as well as to aid in creating of maps and other things, as we spoke about previously. So here we have a combination of latitude and, of course, longitude lines. Okay, and as you can see, latitude lines are pretty interesting to look at. Latitude lines versus longitudinal lines on this. It's kind of nifty to actually see that there. And then of course here's the globe. Let me soften the edges here a bit so that way so we can make it a little smoother, so that way it's a little bit more rounder there. That looks better. So here we have the sphere, and of course within the sphere we have the latitude and longitude lines. Okay, so when we talk about reference system, we're really talking about latitude and longitude lines. Now the Earth is divided by two imaginary lines. So we talked about these imaginary lines. They're the equator and the prime meridian. Now something that's really key about the prime meridian is that the prime meridian crosses exactly over Greenwich, England, and that's key to know. The reason why it's key to know is because in my research and actually trying to find why Greenwich, England was chosen, there were actually 3 places that were chosen to be point 0 on the Earth, and Greenwich, England was one of those places, but it is not the only places. There are maps around the world that actually uses the other 2 places as point 0, which I find really interesting. And that's actually an area of debate and to talk about, because who actually gets to designate point 0, and why do we follow England's? Why can't we follow the other ones? And that's pretty interesting to talk about. But anyway, enough about that. The equator splits the Earth into 2 hemispheres. We know that the equator splits the Earth into 2 hemispheres, and of course here's the equator here. Okay, and we know that it breaks it up into the northern and the southern hemisphere. Okay, if we take these spheres out and we actually look at the equator from top view, I'm sorry, that was left over before, we can actually see that that to actually look at the Earth, if we actually took off both hemispheres, we would be left with just a circle, which means that we can basically handle locations along the surface of the Earth as if we were treating a circle, which comes into angles and degrees. Whenever we want to measure something on the surface of the Earth, we always put the center of the Earth as the first point where we draw the angles from. And then so for example, let's say that this was point A here, okay, and let's say we wanted to know point B, which is here. Okay, what we do is we actually measure, we create an angle that actually goes from one point to the next. Now this creates a degree, and this angle that we have is actually what measures the surface of the earth. Okay, and that's why latitude and longitude lines are in degrees, because they're actually the point zero, the reference point, or should we say the vertex of any angle taken to measure the distance on surfaces of the earth is actually taken at the center of the earth. I don't know if you guys knew that, if that sheds any new light, but that's basically why it's actually measured in degrees. And not only that, in three-dimensional objects, measuring it in degrees is actually a lot easier than measuring it with a straight line, because you get discrepancies when you try to measure it with a straight line. I believe we had a discussion in class before. The reason why we get the discrepancy is because after a certain distance we have to take account that there's an arc, that it actually changes in direction. So there's a curve, and curves actually covers more distance than straight paths. So we had to figure out a new set of mathematics just to measure locations on the earth, and of course we came up with degrees. Now the other one, the other imaginary line that you have to know about, again, is the prime meridian, and it splits the earth into two hemispheres as well. The prime meridian, as we can see here in this picture, this is the prime meridian here, and 180 degrees on the other side is called the anti-prime meridian, and this line actually separates the earth into the western and the eastern hemispheres, as we can see here. And again, just like before, if we were to subdivide the earth into half, we would be left with a plane circle, okay, as you can see here. And again, just like using the as before, if we wanted to find the location on the surface of the earth, okay, from, let's say, from one point to another, what they do is, of course, they create an angle. So they're trying to find the distance between this point to this point, and as you can see, it actually creates a curve along the surface of the earth here. So they want to find this distance, and how do they do it? They basically measure this angle here. Again, just like before, it's just measuring angles, okay? So they measure this angle, and in measuring the angle they can know the distance here of this arc, okay? And that's how they do that. So these are the two imaginary lines, these two reference lines that you have to know of. Now these two reference lines are the beginning points to the reference lines that we currently have, which is latitude and longitude. And latitude and longitude, again, they're measured always when you're given the coordinates of any point. North to south always goes first. It's kind of backwards from actually reading the coordinate system on a, let's say, a Cartesian plane. You know, x-axis always goes first. It's always x point and then y point. When we deal with the surface of the earth, it's always north to south first and then east to west. So it's kind of a little bit backwards. So let's take a look at the next slide here. And in the next slide we say that the Earth's reference system is broken up into latitude and longitude lines, which we actually saw here. Okay, and we can see that they have latitude lines, longitude lines. Okay, now latitude lines run from east to west, but measure how north and south you are from the equator. Does that make sense? Well, let's take a look. Here we have the earth, and we're just going to look at latitude lines. Now I'm just going to go to a side view here. Okay, and we can see that they actually, these latitude lines actually run from north to south. Okay, they run from, I'm sorry, from east to west. They run from east to west, and they measure how up and down you are from the equator. Okay, so if this is the equator, this would be, let's say, 10 degrees from the equator. This would be 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, and of course this would be 90 degrees. So you can see that the latitude lines tells us how north and how south you are, even though they run from east to west. Okay, and that's key to know. Okay, because they run from east to west, but they measure how north and south you are. Just stay with that, because on the test, if I ask you a question like that, you should know that. The other one that we wanted to talk about is longitude lines. And we go back to the notes here, and it says longitude lines run north to south, but they measure how east or west you are from the prime meridian. Again, we look at it again. Assuming this is the prime meridian here, the longitude lines run 180 degrees. Now they measure, they run from north to south, but they measure how far away from the prime meridian you are. So this would be 10, 20, 30, 40, 50, 60, and so forth. So this actually measures the angle from the prime meridian of how far you are. And the reason why I say angle is because every surface, every section on the earth, because it's a sphere, it's a three-dimensional object, it is always going to be curved. So it's going to be measured in angles. Okay? So this is longitude lines and these are latitude lines. Okay? Another thing that I also wanted to show you is that when we look at longitude lines, right? Looking at longitude lines, every line is the same length. It is just one complete circle around the sphere. Notice that every circle on longitude lines have the same distance, and I need you to see this. The other thing I want you to notice is that on latitude lines, the circles are not the same distance. As a matter of fact, the longest latitude line is the equator, which is right here. The equator is the longest latitude line on the surface of the earth. And the longest, and as we go further north, the lines get shorter from the equator. At the equator, going further south, the lines get shorter. In other words, the distance around the circle that the latitude lines make gets smaller and smaller as we go on the inside. And I think that this one actually shows it best. Okay, so what I'm going to do is I'm going to color it by layers, and I'm going to give you a top view. Okay, so each line here is a latitude line, and what I'm going to do is I'm just going to start peeling off the latitude lines. Okay, and I just want you to look at all the things that are here. Right there. Okay, and let me take it off by layers for a moment. And what I want you to see is that the diameter of the latitude line at the top is actually smaller than the diameter of the latitude line below it. And as we get closer and closer to the equator, the latitude lines get longer. Okay, they get longer and longer around this curve. Now, once they hit the equator, they again reduce in size again, continuing downward, making that same shape. Okay, so what we see is we see smaller circles towards the poles, larger circles towards the equator, and the largest latitude line is the equator. Now the next notes that we talk about is we talk about latitude in degrees. Okay, and in the degrees aspect, we know that a degree is 1/360th of a circle. And again, we just go back to this here. We know that this here is actually a circle, and we can measure it in degrees. The really cool thing about this is that the information that we're given to help us to actually do linear measurements. We can turn degrees into linear measurements because we've done enough math, we've done enough experiments to know that if we break up a degree into minutes, and there are 60 minutes in a degree, we can break it up so that every 1 minute of arc is equivalent to 1 nautical mile. What does that mean? That means that we can now measure the distance along that arc. So knowing that there's 60 minutes to a degree and each minute is equal to 1 nautical mile, we can take the degrees and the minutes and even the seconds and calculate distance. And that's the beauty of using this. And I believe that is the end of my session, and I believe I went a little bit beyond the time that I should have been here, but I hope this is helpful.